So, good morning, everyone. So, in earlier classes, we have studied about dispersion measures. So, today, what we will do is that we will come across another concept which is known as correlation analysis or correlation, simply correlation. Okay. So the name itself says that. Before that, I will explain what is correlation. Then, in earlier cases, let us write correlation. So, in most of the earlier cases, what we have dealt is that we have dealt with a single random variable. That was, we had only collected the data about x. So we had find out the mean, median, mode of this particular x. So suppose that we have a bivariate data. So what do you mean by bivariate data? Suppose that I take earlier cases I had taken only one variable, that is x, and it was suppose that it was, for example, it was, we had considered the marks of 50 students or average height of 50 students, like that. Suppose I want to study about two variables, that is two variables I have to study, that is I have to study about height of 50 students, as well as another variable I add, and weight of 50 students. If I want to study about these two variables together, if I want to study about any two variables, for example, here I study about height of a 50 students in a class and weight of 50 students in a class, and these type of data, so it will be in the form xy data will be in this form. For example, it will be in the form, suppose the height is 150 and weight is 50, so next it may be 180, then 100, like this data. So it represents a bivariate data. Okay, this is the meaning of a bivariate data. So as you know that correlation is how much amount of so we can define. So this is actually an example of a bivariate data. Okay, it is an example of a bivariate data. So here there are two random variables, that is variate, two random variables, hence we call them as bivariate data. Okay, it is bivariate data. Okay, so what happens is that we would be interested in studying out the behavior of x and y. Suppose that it is very evident that height of the person, of a healthy person, will be always, I didn't mean that healthy, of a average persons will be almost 100 minus the weight, 100 minus the height will be weight of the person, if you see any relation like this. So we will be interested in studying effect of x and y. Okay, effect of x and y together. So how x varies when y varies and y varies when x varies. Okay, we will be interested in studying the effect of x on y, y on x, like that. There will be many relationships. So this is the basic idea behind dealing of a bivariate distribution. Okay, or bivariate data. This is the basic idea how we deal with a bivariate data. Okay, this is the main idea. And what happens is that we may be at some point of time we will be interested in studying out how much a data is x is related to y. That is how much time the height of the data will be related to weight of the data. At most of the situation, as I have said, that in most of the situation we see that this height will be 100 plus the weight, like that. Some relation we can find out. Okay, in most of the time, if you compare your height and your weight, it will have some sort of relation, or it will not have some sort of relation. For example, if I take x and y as marks of 50 students, okay, and I take let it be weight of 50 students. So weight of 50 students. So it is very evident that these random variables x and y doesn't have any relationship at all. So marks is nothing related to weight. So we have to study about what we say, the relationship amount between random variables. So in correlation we study about different relationship existing between two or more random variables. This is an example of a correlation. This is the basic idea behind the correlation. Okay, this is basic idea behind correlation. So I think that the idea is very clear to you. Now we will say what are the different methods of analyzing correlation, as well as what are the different measures which are used to find how much correlation exists between two or more random variables. Okay, so we will start with writing the basic definition of correlation. We can write correlation as correlation can be so first we will write about a bivariate data or bivariate distribution. So in a data analysis we come across certain distribution involving two variables. Such distributions are called as bivariate distributions. Okay. So here you can consider an example of consider the example of height and weight of 50 students in a class. So or students of not 50, it is not students in a class. So example, so it will be in this manner: height, weight. So height will be 160, 150, 170, like this 167 is correspondingly 60, 57, 70, 100, like this something. Okay, so this is an example of a bivariate data. So we will write one more line. In general, excuse me. So in general, I think that there is sufficient light so that you can see. In general, a bivariate data data values are represented as x1 y1 comma x2 y2 comma xn yn. For example, here you represent this data as 160 60, 150 57, 170 70, 160 700. So this is how we represent a bivariate data. Okay. So we will continue with our class. So next concept is actually correlation. So correlation is simply, as I have already said to you, that it is amount of linear relationship existing between two random variable. Okay, this is the basic definition of correlation. So we will write, okay, it is just represent how much a data is related to, that is how much x is related to y. This measures the amount of it measures the linear relationship actually, okay. This is the basic definition of correlation. So we will write in bivariate data, in bivariate data, in bivariate data, we find whether the two variables under consideration are related or not. In correlation analysis, we study how much data, or how much the variables are related. Then we will write the definition. The two random variables are set to be correlated if the change in one variable makes corresponding change in other variable. Okay. So then we will write the main sentence. Correlation measures amount of linear relationship existing between the variables. Excuse me.